Imagine a universe where cause doesn't always precede effect, a reality where the past isn't fixed and the future whispers back. This isn't science fiction. It's the frontier of quantum physics, challenging everything we thought we knew about time itself. Prepare to have your perception shattered. For centuries, time has been a relentless, linear arrow moving only forward. We experience it as an undeniable progression, from birth to death, cause to consequence. This fundamental understanding underpins our entire existence, our physics, and our very sense of order in the cosmos. But what if this perception is merely a macroscopic illusion? What if, at the smallest scales, the rules we hold so dear begin to fray? Quantum mechanics, the bizarre realm of the very small, consistently defies our classical intuition, hinting at deeper, stranger truths. In the quantum world, particles can exist in multiple states simultaneously, a phenomenon known as superposition. They can also be entangled, linked in such a way that measuring one instantly affects the other, regardless of distance. These are not just theoretical curiosities, they are experimentally verified facts. These quantum oddities force us to reconsider fundamental concepts. If a particle can be in two places at once, or if information can seemingly travel faster than light through entanglement, then our rigid understanding of space and time might be incomplete. The universe is far more flexible than we imagined. One groundbreaking experiment, often dubbed the delayed choice quantum eraser, hints at something truly mind-bending. It suggests that a measurement made in the present can influence the past behavior of a photon. This isn't just about observing, it's about actively shaping history. This experiment involves photons passing through a double-slit apparatus. Depending on how and when we choose to measure their path, the photons either behave as waves or particles. Crucially, the choice made after the photon has passed the slits seems to determine its past. For content creators, this is a goldmine of narrative potential. Imagine explaining these concepts visually, breaking down the complex physics into digestible, engaging stories. Your audience craves knowledge that challenges their worldview and expands their understanding of reality. These experiments aren't just scientific papers. They are profound philosophical statements. They invite us to question the very nature of existence, causality, and free will. This is the kind of content that sparks debate, drives engagement, and builds a loyal, curious community. Another set of experiments explores quantum causality, where the order of events isn't fixed. Particles can exist in a superposition of cause then effect, and effect then cause. This is not classical time travel, but a quantum blurring of temporal sequence. Imagine a scenario where event A influences event B, but simultaneously event B influences event A. This indefinite causal order defies our everyday experience. It suggests that at the quantum level, the arrow of time might not always point in a single unwavering direction. The greatest discoveries are made not in the light, but in the dark. We are on a quest to map the unseen universe. To be a part of this hunt, subscribe to CosmoQuest 888 and activate the notification bell. You will not want to be left in the dark. These experiments highlight the profound role of observation in quantum mechanics. It's not just about passively watching. The act of measurement itself seems to collapse possibilities and define reality. This observer effect is central to understanding these temporal anomalies. For creators, explaining the observer effect is crucial. It's a concept that resonates deeply, touching upon consciousness and reality. Visualizing how a choice in the present can seemingly retroactively determine a past event is a powerful storytelling opportunity. If time isn't strictly linear at the quantum scale, what does that mean for our universe? Could there be implications for cosmology, for the very beginning and end of time? These are questions that push the boundaries of human comprehension and scientific inquiry. These quantum revelations offer a fresh perspective on the universe. They suggest that our classical understanding is merely an approximation, valid for our macroscopic world, but incomplete. The true nature of reality is far more fluid and interconnected than we perceive. Content creators can leverage these mind-bending concepts to create truly unique and impactful videos. Use animations, analogies, and compelling storytelling to make these complex ideas accessible. Your audience will appreciate the intellectual journey you provide. Think about the visual metaphors you can employ. How do you represent a particle existing in a superposition of past and future? How do you illustrate a choice made now, affecting an event that has already occurred? This is where creativity meets cutting-edge science. These experiments are not just isolated curiosities, they are paving the way for new theories of quantum gravity and a unified understanding of the universe. They challenge physicists to rethink fundamental principles and explore uncharted territories of knowledge. The implications extend beyond theoretical physics. Understanding quantum time could unlock new technologies, from quantum computing to entirely new forms of communication. The potential applications are as mind-boggling as the theories themselves. As content creators, you are vital bridges between complex scientific discovery and the curious public. By translating these profound ideas, you empower your audience to engage with the cutting edge of human knowledge and inspire the next generation of scientists. Your platform is a powerful tool for education and inspiration. Embrace the challenge of explaining the inexplicable. Dive into the mysteries of quantum mechanics and share the wonder of a universe that continues to surprise and astound us with its secrets. These quantum experiments suggest a universe far more interconnected than we previously imagined. The boundaries between past, present, and future, cause and effect, might be far more permeable at the fundamental level. This interconnectedness is a profound concept. Consider the philosophical weight of these findings. If time is not absolute, if causality can be blurred, what does that mean for our understanding of free will, destiny, and the very structure of existence? These are questions that resonate deeply with everyone. We are witnessing a paradigm shift in our understanding of time. These quantum experiments are not just breaking records, they are breaking our conventional notions of reality, forcing us to confront a universe that is stranger and more magnificent than we ever dared to conceive. The universe is not a static, predictable machine. It is a dynamic, quantum tapestry, where the rules we thought were immutable are merely guidelines, and the deepest secrets of existence are still waiting to be unveiled by those brave enough to look. 2 quantum experiments have broken time.